Hi, welcome back. In the last video, we looked at our four properties for parallelograms. Number one, they are parallel, my opposite sides are parallel and congruent. Number two, my opposite angles are congruent. Number three, my consecutive, or angles on the same side, are supplementary. And number four, my diagonals will bisect each other. Again, the diagonals don't have to equal each other, but they do have to be divided into two sets of equal segments. Okay? And then we looked at this example and we figured out which of our properties we could use to solve for x and for y. And we ended up using the idea that opposite angles are congruent and set these two equal, but we couldn't solve right away because we had an x and a y. So then we looked at these two sides and said, well, they're on the same side, or these two angles, and said they're on the same side, so consecutive angles are supplementary, which means they add to 180. I was able to find x, plug it in over here so that I could find y. So now let's look at number two. Given that this is a parallelogram, I have information about the pieces that make up the diagonals. So the only property we had that talked about diagonals was this last one that said my diagonals bisect each other. So I know these two pieces will equal each other, and I know these two pieces will equal each other. So my diagonals, my property that I'm using is that diagonals bisect each other. Diagonals bisect each other. Okay, so that's the property that I'm going to be using. When I go to solve, we can do x or y first. It doesn't matter. If I do x first, I know that I have a 4x minus 2 here and an x plus 10 here, and I know that diagonal is divided into two equal pieces. So 4x minus 2 is going to be equal to x plus 10. And this we're going to solve. I'm going to subtract x on both sides to get all my x's together. 4x minus x is 3x minus 2 equals 10. Add 2 to both sides. 3x plus 0 is 3x equals 10 plus 2 is 12. Divide both sides by 3. And 1x equals 4. If we want to check, oops, we couldn't see that. If we want to check, I would do 4 times x. So 4 times 4 is 16, and 16 minus 2 is 14. Over here, 4 plus 10 is also 14. So I can see that these two sides do both have a length of 14. It has been bisected. Okay? When I look at the other diagonal, same thing will hold true. This piece will be equal to this piece. Notice I didn't use single tick marks, I used double tick marks because I already used the singles here, and this diagonal does not have to be equal to this diagonal. So here, my y plus 5 is going to be equal to my 3y minus 1. Okay, when I solve this one, I'm going to subtract y on both sides. I could move my 3y, I could subtract 3y, but I kind of like trying to keep my variables positive when I can. 5 equals 2y minus 1. I'm going to add 1 to both sides. Five plus 1 is 6 equals 2y. Divide by 2. And I'm going to get 3 equals y. Okay, so if we want to check our work, we can plug that in here. If I do 3 plus 5, this length is going to be 8. If I do 3 times 3 minus 1, that's going to be 9 minus 1. 9 minus 1 is also 8. So these two are the same. Now, is my picture to scale? No, it's not, right? This whole diagonal here is 16. This whole diagonal here that looks shorter is actually 28. So remember, your pictures don't have to be to scale. They just have to hold true to the properties of the parallelogram. Okay? In the next video, we will come back and talk about areas of parallelograms. All right, so come on back for the next video.